So now are ready to define what a function is. A function is a mapping or a relation between two sets A and B such that it associates each member of set A to unique members of set B. So there are certain keywords here which can be expanded upon to give us the more expanded or more elaborate definition of functions. Each member. So each member of set A is what it says. So suppose we have set A like this and set B like this. And set A contains certain elements A1, A2 and A3. B contains B1, B2 and B3. So a function associates each member of set A. So this is an exact definition of functions given in a compact way, because the term each member has a lot of weight in this definition. Why? Because a function cannot be defined unless each member of the set A has some unique member in the set B associated with it. You cannot have only a connection between the elements A1 and A2 with elements of the second set and nothing for A3, or just A1 but nothing for A2 and A3, or just A2 but nothing for A1 and A3, and so on. Each member of the set A should have some member in the set B associated with it. So therefore, suppose we have a mapping like this where the elements A1, A2 and A3 of the set capital A and the elements B1, B2 and B3 of the set B are associated with each other such that A1 is associated with the element B1, A2 is associated with B3 and A3 is associated with B2. In such a case, the phrase each member comes into play. So you do not have any member of set A which is left out. That is, it does not have any partner in the set B. Then the other phrase that holds a lot of weight is the phrase unique members of B. So every element of the set A has to have exactly one partner in the set B. So therefore, what I'm about to show in red color is a association which cannot be defined for a function. For example, if A2 is associated with B3 as well as with B1, then this kind of mapping cannot be a function. As simple as that. So that is where the phrase unique members of the set B comes into play. Why is that? Because that is what differentiates functions from ordinary relations, because you can have ordinary relations where such things are allowed, but as far as functions is concerned, specifically with respect to the study of analytic geometry where we require ordinate pairs, where every ordinate pair is unique, you cannot have any element of the set A being associated with more than one element of the set B. So that is why the Yellow arrows denote a mapping, which is a function, whereas the red arrow denotes an illegal or incorrect notation of a function.